Hello, Mr. Eric, Mr. Ryan, am I right?
Yeah, and Mrs. Chesley.
Okay. Okay, so
yeah.
what's anagram? Come on.
An anagram is two words that use the same letters. Anagrams.
Anagrams. Okay, so can you give me an example of the anagrams? Two anagrams.
Go down.
Rice.
Rice.
And Eric.
Where now?
Listen and silent.
Listen.
Eat tea and ate.
E-T. Okay, that's a very good example. Eight. A-T, yeah? Okay, so basically,
A and A.
that's enough. Basically, these words are anagram because they use the same number of characters. And each character is the same number, okay? Yeah? So look, for example, E-A-T. E1s, A1s, T1s. E1s, A1s, T1s. E1s, A1s, T1s, okay? And listen, rise as well. Just different order. If we sort those anagrams, what happens? If we sort the anagrams, what do we get?
We get of anagrams.
So let's put it in another way. So if we sort these anagrams,
Tuple.
what do we get for this one? If we sort it, A-E-T. If we sort this, A-E-T. If we sort this, A-E-C. Do you see what I'm getting?
Yeah.
So if we saw this, C, E-I-R, okay? The same. So basically we're saying that if the anagrams, we sort it and we get the same words, same string, okay? Yeah? So today's question will be, we are given a list of words.
And we have to group the anagram.
Yeah, we want to group it. So how do we do it? I mean,
Dictionary.
we use dictionary, yeah. So we use the dictionary. Before dictionary, the keys, we can do it with the sorted, yeah. Because we said if we sort the anagram, we get the same thing, yeah. So the keys will be sorted, and the value will be the list of the anagrams belong to the same group, okay? Yeah, make sense?
Yeah.
So default dictionary, yeah. The default type will be the list. So define group. Anagram, okay? And I'm given this word. So first of all, we have this data equals default dictionary. Default dictionary, we'll talk about that lots of times. This is a class from the collections, yeah? From collections import default dictionary. And the default type will be the list of words. Now we go through this word, W in word. Go through this word, and then look, this is word, okay? Then what do? We sort it. So that's a sorted version, sorted W. Then we can change it to tuple, yeah, to make it hashable, yeah, hashable. Because the keys needs to be hashable. But append, right? Append W, and then we just need to return data.value, yeah, because that's the thing we are going to return. Return the list. So basically, we're going to return this data.values. What's data value? So it will be something like EAT, ATE, okay? And then it will be a list of the anagram. So the sublist will be a group for the anagram. So there'll be listen and silent. Right? The keys will be the sorted version of the anagram. Right? Yeah. What's the time complexity for this one?
O-N.
Yeah, no. Why is it O-N? Look.
O-N again.
Okay, so you're part of the look. We are going through if there are n words. So n word, yeah. And let's say the maximum length will be k.
O-N times K.
Not quite, because we have a sorted. So if we're saying the length will be k for the words. So this part.
O-N
This.
square.
Come on, don't guess. This part takes OK log k. If the length of the W is k, but we have n times, so we times n. Okay, so it's O(n) times k log k. Okay, yeah, because we have sorting here. Yeah, sorted. So the other approach is slightly different, right? The thing. Come on, the thing this is slow because we have the sorting here. Sorted. We need to sort each word, right? So we can count. The other way to check if two strings are anagram, we just need to count, right? Remember we use the counter, yeah? Counter is basically, if we want to check string A and B, if they are anagram, we just say return counter A equal counter B, right? Yeah, we talked about that. But the thing is, this counter is an object, right? So how do we put in it as a key? So we can just do this. We can just do this D. We can have this. If these words are all lowercase, then we have 26. Yeah, we have 26 characters, and we want to count. Let's create an array, and then we can do this. For C in W, D ORD C minus 97 plus equals 1, and then this thing data. That's data tuple. We convert this to tuple. Tuple D dot append. This is the same. Okay, so then let me explain this. D, this is an array of 26. This is an array of 26 elements, representing the counter, the number of times that for each alphabetic lowercase character used. Okay, and we go through each word, and then we update. What's ORD? Do you still remember ORD and CHR? ASCII. Yeah, we talk about ASCII. What's the ASCII of the uppercase A?
I forgot.
65. What's the lowercase a? 97. Okay, so the ORD is converting a character to the number, to ASCII code. Minus 97, right? Because the lowercase a is 97. Minus 97 equals 0. So it corresponds to the first element, okay? Yeah? So look, so instead of sorting, we count. We do the counting. And then we convert this counting. This is an array, we convert it to a tuple. Then we can use it as a key to the dictionary, right? So the time complexity, look, if there are n words, and each word is k, so this time complexity is O n times k, okay? The space complexity for both cases is O n times k, right? Because the n words k, yeah, the dictionary, okay? Did you get it? What have you learned today so far? Come on, everybody.
About anagrams.
Anagram. What are we doing with this anagram?
Sort of them into groups.
Yeah, and how do we do it? What we talk about a very important data structure here. We use what?
Use dictionary.
Yeah, key value pairs. Yeah. The keys will be important to group the anagrams, right? Because each anagram group has the unique keys. So we can sort it. Yeah, we can sort the anagrams in the same group, and then they all produce the same key, right? Or we can count it, right? We can count. We can do the counting for the characters, yeah? So which one do you think is better? Okay, so look, these two time complexity. This one is O n times k. The first one, we all use the sorting, it will be O n times k log k. So which one is better?
O-N times K.
Okay, that's it for today. Bye-bye.
Bye.
Bye. Bye. Good job.